Imagine an alien world covered in ice, hiding a vast ocean beneath its frozen crust. What if I told you this ocean might be teeming with extraterrestrial life? Sounds like science fiction, right? Well, NASA's latest discoveries are rewriting the rules of astrobiology. Recent data from the James Webb Space Telescope and NASA's upcoming Europa Clipper mission hint at something truly shocking. Chemical signatures, water plumes, and possible energy sources that could sustain alien organisms beneath the icy shell of Jupiter's moon Europa. The presence of liquid water is just the beginning. Scientists have found evidence suggesting Europa's ocean contains the essential ingredients for life: organic molecules, energy sources, and potentially even microbial ecosystems. If proven, this discovery would change everything we know about life in the universe. Stay with us as we uncover NASA's latest findings, the technology being used to explore Europa, and what all of this could mean for the search for extraterrestrial life. This might just be the most important discovery of our lifetime. Before we dive in, don't forget to subscribe to Infinitia Verity for mind-blowing space discoveries and hidden truths of the cosmos. Hit the bell icon so you never miss an episode. The search for extraterrestrial life often takes us to distant star systems, hoping to find an Earth-like planet orbiting in a habitable zone. But what if the answer has been right here in our own backyard all along? Enter Europa, one of Jupiter's most intriguing moons, an ice-covered world that holds a deep global ocean beneath its frozen shell. For decades, scientists have suspected that Europa could be one of the best places to look for life beyond Earth. But what makes this tiny, frozen moon so special? How do we discover its hidden ocean? And what do we really know about its potential to harbor life? Let's go back in time. The year is 1610. Italian astronomer Galileo Galilei has just pointed his telescope at Jupiter and made a discovery that would change our understanding of the universe. He identifies 4 large moons orbiting the gas giant. One of them is Europa. For centuries, Europa was just another distant celestial body. But everything changed in the 1970s when NASA's Pioneer 10 and 11 spacecraft flew past Jupiter and provided our first up-close images of Europa's surface. What they found was shocking. Instead of a cratered rocky landscape like our moon, Europa's surface was eerily smooth, covered in what appeared to be a vast sheet of ice. Even more mysterious were the strange dark streaks and cracks stretching across its frozen surface, markings that didn't quite resemble anything we had seen before. Fast forward to the 1990s. NASA launches the Galileo spacecraft, specifically designed to study Jupiter and its moons. Over the course of multiple flybys between 1995 and 2003, Galileo makes one of the most profound discoveries in planetary science: evidence of a massive, global ocean hidden beneath Europa's icy shell. But how did Galileo detect this ocean without ever touching the surface? The answer lies in something invisible: the moon's magnetic field. Scientists at NASA's Jet Propulsion Laboratory, led by planetary scientist Margaret Kaivelson, analyzed Galileo's magnetometer data and found something unexpected. The magnetic field around Europa was behaving strangely, as if it was interacting with a conductive liquid layer beneath the surface, most likely a salty ocean. This discovery was monumental. It meant that Europa wasn't just a frozen wasteland, it was a dynamic world with a liquid water ocean beneath its ice crust. And wherever we find liquid water on Earth, we find life. Could the same be true for Europa? Now let's talk about the sheer size of this ocean. Europa's ice shell is estimated to be 10 to 30 kilometers thick, but beneath that ice lies an ocean that is believed to be over 100 kilometers deep, far deeper than any ocean on Earth. In fact, Europa's ocean could contain twice as much liquid water as all of Earth's oceans combined. This is where things get really exciting. We aren't just talking about small underground pockets of water. This is a vast global ocean covering the entire moon, circulating beneath its frozen crust. But how does it stay liquid in the frigid environment of deep space? The answer is something called tidal heating. Because Europa orbits so close to Jupiter, it experiences intense gravitational forces that cause its interior to flex and generate heat. This process, known as tidal flexing, is what keeps Europa's ocean from freezing solid, and it may also drive underwater volcanic activity, a key factor in supporting life. Here's the big question. If Europa has a stable liquid ocean, could it also have life? To answer that, we need to look at 3 essential ingredients that all life on Earth requires: liquid water, chemical building blocks, and an energy source. We already know that Europa has water, a whole planet's worth of it. But what about chemistry and energy? The latest research from NASA suggests that Europa's ocean is likely rich in minerals and organic compounds, thanks to interactions between the ocean and the rocky seafloor. But the real game changer is energy. On Earth, life thrives near deep-sea hydrothermal vents, volcanic openings on the ocean floor that release heat and chemicals, providing energy for an entire ecosystem of strange, alien-like creatures. If similar hydrothermal vents exist at the bottom of Europa's ocean, they could create an environment capable of supporting microbial life. In other words, Europa's ocean could be more than just a sterile body of water. It could be an active, habitable environment teeming with life forms unlike anything we've ever seen before. Given all this evidence, it's no surprise that Europa has become one of NASA's top priorities in the search for extraterrestrial life. The Europa Clipper mission, launched in October 2024, is the most advanced spacecraft ever sent to study this mysterious moon. Equipped with cutting-edge scientific instruments, the Europa Clipper will conduct nearly 50 flybys, using high-resolution cameras, ice-penetrating radar, and spectrometers to analyze Europa's surface, its atmosphere, and most importantly, its subsurface ocean. But here's where things get really exciting. Recent discoveries suggest we may not even need to drill into Europa's ice to study its ocean. Why? Because of something incredible, gigantic water plumes shooting into space. And that's exactly what we're going to explore next. We now know that Europa is more than just a frozen moon. It's an alien ocean world, filled with liquid water and possibly even deep-sea volcanoes. But could we get a direct sample of this water without landing? The answer might lie in Europa's towering water plumes, geysers that erupt from its surface, releasing vapor into space. Coming up next, we'll examine NASA's latest discoveries about these plumes, how they contain the key building blocks of life, and what it means for future missions. Stay tuned because the evidence for extraterrestrial life just got even stronger. Now that we know Europa is home to a vast global ocean beneath its icy surface, a crucial question remains: how can we study it without drilling through kilometers of ice? The answer might already be shooting into space. In 2012, NASA made a discovery that stunned the scientific community. Gigantic plumes of water vapor erupting from Europa's surface, reaching heights of over 200 kilometers, that's 124 miles. If these plumes are connected to Europa's subsurface ocean, they could provide a direct sample of what lies beneath without ever touching the surface. And here's where it gets even more interesting. Recent data from the James Webb Space Telescope, JWST, and NASA's Hubble Space Telescope confirm that these plumes are not just spewing water, they contain essential ingredients for life. So, what exactly did NASA discover, and what does it mean for the search for extraterrestrial life? Let's dive into the science behind these mysterious water plumes. The first hints of Europa's water plumes came from NASA's Hubble Space Telescope in 2012. Astronomers using Hubble's ultraviolet imaging instruments detected a faint but unmistakable signature, evidence of water vapor erupting from Europa's south pole. The study, led by planetary scientist Lawrence Roth of the Southwest Research Institute, provided the first-ever confirmation of an active water plume on Europa. But here's the fascinating part. This wasn't the first time scientists suspected Europa had such activity. Earlier in 2005, NASA's Cassini spacecraft, while exploring Saturn's moon Enceladus, discovered similar water plumes erupting from its icy surface. These plumes contained water, organic molecules, and even salts, raising the possibility of habitable environments beneath Enceladus's ice. Scientists speculated that Europa, which shares similar characteristics with Enceladus, might also have plumes, and Hubble's 2012 discovery finally provided the first supporting evidence. However, there was a problem. Hubble could only detect the plumes intermittently, and the data was not strong enough to confirm whether these plumes were truly connected to Europa's subsurface ocean. More powerful instruments were needed to verify their existence. Fast forward to May 2023, the James Webb Space Telescope, JWST, the most advanced space observatory ever built, was turned toward Europa. Using its highly sensitive spectrographs, JWST detected massive plumes of water erupting from Europa's surface, stretching over 9,600 kilometers, that's 6,000 miles, into space. To put that into perspective, that's more than 7 times the diameter of Europa itself. But here's where things get even more exciting. JWST didn't just confirm the existence of the plumes, it also identified their chemical composition. Scientists found that these plumes contained water vapor, essential for all known life. Carbon dioxide, a key ingredient in biological processes, sodium chloride, the same kind of salt found in Earth's oceans, and potential organic molecules, the building blocks of life. This was a game-changing discovery. The presence of carbon dioxide suggests active geological processes beneath Europa's ice, possibly involving hydrothermal vents at the ocean floor, similar to those on Earth where life thrives in complete darkness. Now you might be wondering, do these plumes actually originate from Europa's deep ocean, or are they just surface-level eruptions? Scientists have analyzed the chemical composition of the plumes and compared them to what we would expect from an ocean that has been in contact with Europa's rocky mantle. The findings suggest a direct connection. A 2019 study led by Jianzhe Jia, a planetary scientist at the University of Michigan, used data from NASA's Galileo spacecraft to reconstruct Europa's magnetic field disturbances. Their conclusion? The water plumes are likely coming from an underground reservoir of liquid water, possibly linked directly to Europa's ocean. This is huge because it means future spacecraft won't need to land on Europa or drill through its ice to sample its ocean. Instead, they can simply fly through the plumes, collect water samples, and analyze them for biosignatures, potential evidence of alien life. So what kind of life could exist in these plumes? If microbes are living in Europa's ocean, some of them might get carried up by the plumes and ejected into space. Scientists have compared this process to geysers on Earth, such as those in Yellowstone National Park, where microbes thrive in extreme environments. Let's consider 2 possible scenarios for life in Europa's ocean. Scenario 1, microbial life similar to deep-sea bacteria. On Earth, scientists have found bacteria living near deep-sea hydrothermal vents, places where heat and chemicals from the Earth's interior provide energy for life. These organisms don't rely on sunlight but instead use a process called chemosynthesis to survive. If Europa has similar deep-sea vents, life could thrive in the same way. Scenario 2, more complex life forms. If Europa's ocean has existed for billions of years, it's possible that life has evolved beyond simple microbes. Some astrobiologists speculate that Europa could host more complex, multicellular organisms, perhaps even shrimp-like creatures, similar to those found in Earth's deep-sea ecosystems. But how will we know for sure? The answer lies in an upcoming mission that will change everything: NASA's Europa Clipper. We now have overwhelming evidence that Europa's plumes contain essential ingredients for life, but we need direct samples to confirm the presence of biosignatures. That's where NASA's Europa Clipper comes in. Set to launch in October 2024, this ambitious spacecraft will fly directly through these plumes, collecting data and searching for life. Coming up next, we'll explore the groundbreaking technology on board the Europa Clipper, how it will analyze Europa's ocean, and what it could reveal about the existence of extraterrestrial life. We now know that Europa is not just an icy moon, it's a world of possibilities. Beneath its frozen shell, a vast global ocean churns, possibly harboring the ingredients for life. And thanks to NASA's Hubble and James Webb Space Telescopes, we've discovered that enormous plumes of water rich in carbon dioxide and organic compounds are erupting from the surface, giving us direct access to the secrets hidden beneath. But to truly unlock Europa's mysteries, we need more than telescopes. We need a spacecraft that can get up close, scan beneath the ice, and even fly through the plumes to collect samples directly. This is where NASA's Europa Clipper comes in, a mission designed to answer one of the greatest questions in human history: are we alone? Set to launch in October 2024, the Europa Clipper will be the most advanced spacecraft ever sent to study an ocean world beyond Earth. It won't land, but it will perform nearly 50 close flybys of Europa, gathering high-resolution images, scanning the ice with radar, and analyzing its water plumes for signs of life. This mission could redefine astrobiology forever. The idea of sending a dedicated mission to Europa has been around for decades, but funding and technological challenges delayed its development. In the early 2000s, NASA proposed several ideas, including an ambitious concept called the Europa Orbiter, which would have mapped Europa's surface and magnetic field. However, Budget constraints forced NASA to cancel the mission. The breakthrough came in 2013 when the U.S. Congress, under pressure from planetary scientists, specifically allocated funding for a new Europa mission. NASA officially approved the Europa Clipper in 2015, and by 2019, construction had begun at the Jet Propulsion Laboratory in California. With a total budget of $5 billion, the Europa Clipper is one of the most expensive planetary exploration missions ever undertaken. Unlike previous missions, which only made brief flybys, Europa Clipper is designed for long-term, high-resolution exploration. But how will it get there? And what exactly will it do? Reaching Europa is no easy task. Jupiter is over 628 million kilometers, or 390 million miles from Earth, and a direct journey would take too much fuel. Instead, Europa Clipper will use a gravity assist maneuver, meaning it will first swing around Venus and then back past Earth to gain speed. This technique will allow it to reach Jupiter in 2030, 6 years after launch. Once it arrives, it won't orbit Europa directly. Instead, it will stay in orbit around Jupiter and perform nearly 50 flybys of Europa, each time coming as close as 25 kilometers or 16 miles above the surface. This strategy minimizes the spacecraft's exposure to Jupiter's extreme radiation, which could otherwise fry its electronics. But what will the Clipper actually do when it gets there? Let's explore its groundbreaking technology. Europa Clipper is armed with 10 state-of-the-art scientific instruments, each designed to answer specific questions about Europa's ice, ocean, and potential for life. Let's break down some of the most exciting ones. First, we have the Ice Penetrating Radar, or REASON, which stands for Radar for Europa Assessment and Sounding Ocean to Near Surface. This powerful radar will use radio waves to scan deep beneath Europa's surface, mapping the thickness of the ice and identifying possible pockets of liquid water. If Europa has underground lakes similar to those found beneath Antarctica's ice sheets, REASON could find them. This would be a game changer, as such lakes might be more accessible for future landers. Next up are the mass spectrometers, mass specs and SUDA, which will be crucial for sniffing for life. Mass specs, or mass spectrometer for planetary exploration, analyzes the chemical composition of Europa's thin atmosphere and plumes looking for biosignatures. SUDA, or surface dust analyzer, detects microscopic particles from the surface and plumes, identifying organic molecules and salts. If these instruments detect complex organic compounds such as amino acids or lipids, it could be the strongest evidence yet that Europa's ocean is habitable. Finally, we have the ultraviolet spectrograph, or Europa UVS, which is designed for finding hidden plumes. Europa's plumes are unpredictable and we don't know when or where they will erupt. Europa UVS will scan the surface for active plumes, helping scientists determine when and where to collect samples. If a powerful eruption is detected, Europa Clipper can adjust its trajectory to fly directly through it, maximizing the chances of detecting biosignatures. The ultimate goal of Europa Clipper is to detect biosignatures, chemical or physical evidence that suggests biological activity. But what exactly are scientists looking for? Possible biosignatures in Europa's plumes include amino acids, the building blocks of proteins essential for all known life; lipids, fat-like molecules used to form cell membranes; methane or other gases which on Earth are often produced by living organisms; and complex organic molecules, large carbon-based molecules that suggest biological processes. If any of these are found in Europa's plumes, it wouldn't necessarily prove life exists. But it would be strong evidence that Europa's ocean is a habitable environment, potentially teeming with microbial life. Europa Clipper is just the beginning. Scientists are already discussing the next step, a lander mission that would drill through Europa's ice and directly explore its ocean. Future mission concepts include cryobots. These melting robots could melt through Europa's ice shell and explore its ocean, and autonomous drones, miniaturized flying robots that could navigate through subsurface lakes. Some scientists speculate that within 50 to 100 years, humans could visit Europa, much like we plan to explore Mars. If Europa Clipper finds compelling evidence of biosignatures, a lander mission will likely follow within the next 2 decades. And if we confirm that life exists beyond Earth, it would be the biggest discovery in human history. The search for life on Europa is reaching a critical moment. With Europa Clipper set to launch soon, we are on the brink of a major breakthrough. But if Europa's ocean is habitable, what kind of life might we find? Could alien creatures be swimming beneath the ice? And how would it compare to life on Earth? Coming up next, we'll explore the possibilities of what alien life on Europa could actually look like. From microbes to complex deep-sea organisms, we'll examine how life might evolve in a completely different world. The possibility of life beyond Earth has fascinated scientists, philosophers, and science fiction fans alike for centuries. But what if life isn't light years away in a distant galaxy? What if it's right here in our own solar system, beneath the frozen shell of Europa? Europa is one of the most promising candidates for extraterrestrial life. We know that it has a vast ocean, likely in contact with a rocky seafloor. We also know that hydrothermal activity might be occurring deep beneath the ice, creating energy sources that could sustain life just like the deep-sea ecosystems on Earth. But what kind of life are we talking about? Are we expecting tiny alien microbes, or is there a possibility of something more complex? To answer this question, let's explore how life survives in extreme environments on Earth, and what that tells us about the potential creatures lurking in Europa's hidden ocean. Every living organism on Earth, whether it's a single-celled bacterium or a complex whale, relies on three essential ingredients: liquid water, chemical building blocks, and an energy source. Liquid water. Europa has an entire global ocean of it. Chemical building blocks. Elements like carbon, nitrogen, oxygen, and phosphorus are crucial for life and might exist in Europa's ocean. Energy source. Hydrothermal vents or chemical reactions could provide the necessary energy. With all three of these in place, the conditions for life may be met. But what kinds of organisms could thrive in such an extreme environment? To predict what Europa's life might look like, we don't need to look to alien planets. We just need to look at some of Earth's most extreme environments. Meet the extremophiles, organisms that survive where life shouldn't exist. First, deep-sea hydrothermal vent organisms. Deep in Earth's oceans, at depths where sunlight never reaches, there exist entire ecosystems fueled not by the sun but by chemical reactions. Near hydrothermal vents, cracks in the seafloor where heated water and minerals pour out, scientists have discovered bizarre creatures that thrive in total darkness. For example, the giant tube worm, scientifically known as Riftia pachyptala, is found near hydrothermal vents at depths of over 2,500 meters, or 8,200 feet. It lacks a mouth and stomach and relies on bacteria that convert chemicals like hydrogen sulfide into energy. These tube worms can grow up to 2.4 meters or 8 feet long in complete darkness. If Europa's ocean has hydrothermal vents, similar organisms could exist there, feeding on the chemicals released from the ocean floor instead of relying on sunlight. Next, let's consider Antarctic subglacial lakes' life in total isolation. Earth's coldest environments may also provide clues about Europa. In Antarctica, beneath 4 kilometers or 2.5 miles of solid ice lies Lake Vostok, one of the most isolated bodies of water on the planet. Scientists drilled into this hidden lake and found living microbes that had been cut off from the rest of the world for millions of years. For instance, microbes in Lake Vostok are found beneath 4 kilometers of Antarctic ice, similar to Europa's ice shell. They survive in complete darkness with limited nutrients, suggesting that microbes could survive beneath Europa's ice in a similar way. If life can exist in Lake Vostok, it's reasonable to think it could also survive in Europa's much larger, much deeper ocean. While most scientists believe that if life exists on Europa, it is likely microbial, some astrobiologists suggest that complex, multicellular organisms, perhaps even alien fish, could have evolved in its deep ocean. But what conditions would be required for complex life to emerge? Stable energy source? Constant hydrothermal activity could sustain more than just microbes. Oxygen-rich water. If Europa's ice allows oxygen to seep into the ocean, larger organisms could evolve. Millions or even billions of years of evolution. More time means more chances for life to become complex. Some researchers believe that Europa's ice may allow oxygen to mix into the ocean over time, creating conditions that could support more advanced, energy-demanding life forms. According to Hand and colleagues in 2017 from the NASA Astrobiology Institute, this is a real possibility. Hypothetical example, alien crustaceans. If life followed a similar evolutionary path to Earth, creatures like shrimp or jellyfish-like organisms could exist, feeding on microbes or chemical energy sources. Earth's deep-sea shrimp thrive in darkness using chemosynthesis. Why not on Europa? But to find out for sure, we need a mission that can directly explore Europa's ocean, and that's exactly what scientists are planning next. The Europa Clipper will tell us whether Europa's ocean has the right conditions for life. But to actually find and study living organisms, scientists will need to send a mission capable of penetrating the ice and diving into the ocean itself. Future mission concepts include cryobot submarines, robots that melt through the ice, then deploy small submarines into the ocean. Autonomous ocean drones, miniaturized underwater drones designed to explore Europa's deep ocean. Ice drilling landers that drill through the ice to directly sample water beneath the surface. NASA's Aquanaut concept in 2023. In 2023, NASA engineers proposed a nuclear-powered cryobot that could drill through Europa's ice and release a submarine-like drone into the ocean. This drone would use sonar and cameras to search for life, perhaps even capturing the first images of extraterrestrial creatures. But even if life is found, the implications go beyond just Europa. Long-term goals and the possibility of human missions beyond Mars. Stay tuned. We are on the brink of a scientific revolution. The evidence is mounting that Europa is not just another icy moon. It's an alien ocean world, with the key ingredients for life: liquid water, energy, and organic chemistry. With the upcoming Europa Clipper mission set to launch in 2024, we are closer than ever to answering the age-old question, are we alone in the universe? But the search for life on Europa is just the beginning. What happens if we find signs of alien microbes? What are the next steps in our quest to explore Europa's hidden ocean? And could humans one day set foot on this distant world? In this final segment, we'll dive into the future of Europa exploration, from next-generation robotic missions to the possibility of sending astronauts to Jupiter's moon. The Europa Clipper, scheduled to launch in October 2024, will be the first dedicated spacecraft designed to study Europa in high detail. We've already discussed its groundbreaking scientific instruments, including ice-penetrating radar, spectrometers, and cameras that will map Europa's surface and atmosphere. But what happens once Europa Clipper arrives at Jupiter in 2030? The mission will unfold in multiple phases. Phase 1, initial flybys, from 2030 to 2031. The spacecraft will perform the first high-resolution scans of Europa's surface. It will search for active water plumes and map their locations. Scientists will analyze data to select the most promising sites for habitability. Phase 2, targeted investigations, from 2031 to 2033. Closer flybys will allow Europa Clipper to fly directly through water plumes, collecting samples. The ice-penetrating radar will scan for subsurface lakes beneath the crust. Spectrometers will analyze Europa's chemistry for potential biosignatures. By 2033, NASA expects to have an enormous data set about Europa's composition, ocean activity, and potential for life. But even if we find strong evidence of habitability, there will still be one major problem. We won't have direct proof of life itself. To get that, we'll need a lander mission. If Europa Clipper confirms that Europa's ocean contains complex organic molecules, or even hints at biological activity, the next logical step will be to land on Europa's surface and drill beneath the ice. NASA has already proposed a concept for a Europa lander, a spacecraft designed to touch down on Europa, collect ice samples, and analyze them for direct signs of life. While no official mission has been approved yet, scientists are already designing the technology needed to make this a reality. Key features of the proposed Europa lander include an autonomous drilling system capable of drilling up to 10 centimeters, or 4 inches, into the ice to extract subsurface samples. An onboard lab equipped with a miniature biological laboratory to analyze samples for amino acids, lipids, and microbial life. Radiation shielding, because Europa is bathed in Jupiter's intense radiation, so the lander must be heavily shielded. And a short mission time. Due to radiation exposure, the lander may only survive 20 to 30 days on the surface. If this mission is approved, it could launch as early as the 2040s. And if it finds fossilized or living microbial life, it will be the greatest discovery in human history. But why stop at microbes? Could we eventually send a robotic submarine into Europa's ocean itself? The Europa Clipper will tell us whether Europa's ocean has the right conditions for life. But to actually find and study living organisms, scientists will need to send a mission capable of penetrating the ice and diving into the ocean itself. Future mission concepts include cryobot submarines, robots that melt through the ice, then deploy small submarines into the ocean. Autonomous ocean drones, miniaturized underwater drones designed to explore Europa's deep ocean. Ice drilling landers. Landers that drill through the ice to directly sample water beneath the surface. In 2023, NASA engineers proposed a nuclear-powered Cryobot that could drill through Europa's ice and release a submarine-like drone into the ocean. This drone would use sonar and cameras to search for life, perhaps even capturing the first images of extraterrestrial creatures. But even if life is found, the implications go beyond just Europa.
If life exists on Europa, it changes everything. It would mean that life is not unique to Earth, that under the right conditions it can emerge elsewhere in the universe. Life beyond Earth is likely. If it happened twice in our own solar system, it's likely happening on countless exoplanets. A new definition of habitability, no longer limited to Earth-like planets, but ice-covered worlds too. Implications for Mars and Enceladus. If Europa has life, other icy moons or planets might as well. The discovery of even a single alien microbe would be one of the most profound moments in human history. And the first clues might already be drifting through Europa's plumes, waiting for us to find them. We've explored the possibilities of life on Europa, but the biggest question remains, what's next? What happens if we find biosignatures? Could humans one day travel to Europa just as we plan to visit Mars? In the final segment, we'll discuss the future of Europa exploration, NASA's long-term goals, and the possibility of human missions beyond Mars. Stay tuned. We are on the brink of a scientific revolution. The evidence is mounting. Europa is not just another icy moon. It's an alien ocean world, with the key ingredients for life: liquid water, energy, and organic chemistry. With the upcoming Europa Clipper mission set to launch in 2024, we are closer than ever to answering the age-old question, are we alone in the universe? But the search for life on Europa is just the beginning. What happens if we find signs of alien microbes? What are the next steps in our quest to explore Europa's hidden ocean? And could humans one day set foot on this distant world? In this final segment, we'll dive into the future of Europa exploration, from next-generation robotic missions to the possibility of sending astronauts to Jupiter's moon. The Europa Clipper, scheduled to launch in October 2024, will be the first dedicated spacecraft designed to study Europa in high detail. We've already discussed its groundbreaking scientific instruments, including ice-penetrating radar, spectrometers, and cameras that will map Europa's surface and atmosphere. But what happens once Europa Clipper arrives at Jupiter in 2030? The mission will unfold in multiple phases. Phase 1, initial flybys from 2030 to 2031. The spacecraft will perform first high-resolution scans of Europa's surface. It will search for active water plumes and map their locations. Scientists will analyze data to select the most promising sites for habitability. Phase 2, targeted investigations from 2031 to 2033. Closer flybys will allow Europa Clipper to fly directly through water plumes, collecting samples. The ice-penetrating radar will scan for subsurface lakes beneath the crust. Spectrometers will analyze Europa's chemistry for potential biosignatures. By 2033, NASA expects to have an enormous data set about Europa's composition, ocean activity, and potential for life. But even if we find strong evidence of habitability, there will still be one major problem. We won't have direct proof of life itself. To get that, we'll need a lander mission. If Europa Clipper confirms that Europa's ocean contains complex organic molecules, or even hints at biological activity, the next logical step will be to land on Europa's surface and drill beneath the ice. NASA has already proposed a concept for a Europa lander, a spacecraft designed to touch down on Europa, collect ice samples, and analyze them for direct signs of life. While no official mission has been approved yet, scientists are already designing the technology needed to make this a reality. Key features of the proposed Europa lander: an autonomous drilling system, capable of drilling up to 10 centimeters or 4 inches into the ice to extract subsurface samples. An onboard lab, equipped with a miniature biological laboratory to analyze samples for amino acids, lipids, and microbial life. Radiation shielding, as Europa is bathed in Jupiter's intense radiation, so the lander must be heavily shielded. And a short mission time, due to radiation exposure, the lander may only survive 20 to 30 days on the surface. If this mission is approved, it could launch as early as the 2040s. And if it finds fossilized or living microbial life, it will be the greatest discovery in human history. But why stop at microbes? Could we eventually send a robotic submarine into Europa's ocean itself? If we truly want to understand what lies beneath Europa's ice, we will need to send a submarine into its ocean. This is one of the most ambitious ideas in astrobiology, and while the technology doesn't exist yet, NASA and other space agencies are actively researching concepts for such a mission. NASA's Cryobot concept, 2023. A nuclear-powered probe would melt through several kilometers of ice, reaching the ocean. Once inside, it would release a small robotic submarine equipped with cameras and sensors. The submarine would explore the ocean, searching for signs of microbial life or even complex alien creatures. This type of mission is decades away from becoming reality, but it represents the ultimate goal of Europa exploration. The day we send a robotic submersible into Europa's ocean will be the day we truly explore an alien sea for the first time. Europa is one of the most inhospitable places in the solar system. Jupiter's intense radiation, the extreme cold of -160 degrees Celsius, and the thick ice shell make human exploration incredibly challenging. But could we ever send astronauts to explore Europa firsthand? Radiation protection. Europa receives 1,800 times the radiation that Earth does, requiring underground habitats or magnetic shielding. Landing challenges. Unlike Mars, Europa has no atmosphere, making landing more complex. Energy sources. Solar power is weak due to distance from the sun, requiring nuclear energy sources for human survival. Despite these challenges, some scientists believe that in the next 100 years, human missions to Europa could become feasible. The key will be advancements in nuclear propulsion, space radiation shielding, and ice drilling technology. Future concepts for a human Europa mission: Jupiter Space Station. A space station orbiting Jupiter to coordinate robotic missions. Europa Ice Base, a subterranean human habitat built beneath the ice to protect from radiation. Subsurface exploration vehicles, miniaturized submarines piloted remotely from an orbiting spacecraft. While this might sound like science fiction, keep in mind that 100 years ago, spaceflight itself was a fantasy. If technological progress continues, a human mission to Europa could become reality within our lifetimes. Let's take a moment to consider what's at stake. If we find microbial life on Europa, it will mean that life is not unique to Earth. It will suggest that the universe is teeming with life, waiting to be discovered. But if we find nothing, if Europa is barren despite all the right conditions, it could mean that life is far rarer than we think. 3 possible outcomes. We find microbial life. This would confirm that life is common in the universe and could exist elsewhere. Europa's ocean is sterile. This would suggest that life requires more than just water and chemistry. It needs something we don't yet understand. We find fossilized life. If Europa had life in the past but not now, it would raise questions about why life vanished. Was there a mass extinction event in an alien ocean? Either way, the search for life on Europa is not just about one moon. It's about understanding life's place in the universe. Are we alone? Or is life an inevitable consequence of cosmic evolution? Europa is one of the most exciting places in the solar system. With the Europa Clipper set to launch soon and future missions in development, we are closer than ever to answering one of humanity's greatest questions. So, what do you think? Will we find alien life in Europa's ocean? Could a robotic submarine one day capture the first image of an extraterrestrial creature? Let us know your thoughts in the comments. If you love exploring the mysteries of the universe, subscribe to Infinitia Verity and stay curious because the truth is always out there.